Okay, so this is going to be the mathematical reasoning section of your board game. So my instructions here are an explanation of the mathematical reasoning of your game. Why'd you make the choices you made regarding your probability events? That's the main question right there. Why are some outcomes more likely than others? How does the probability or expected value of different outcomes affect your strategy? So note that you don't need to answer these questions specifically. They're just guideposts for you to start thinking about your answer here. Mostly, I want you to explain why you made the choices you made regarding your probability events and how those affect the game. So as an example, we're going to start with my first pretend game here, where I roll, and if I get a 1-2, I draw from the move deck. If I roll a 3-4, I draw from the gold deck. And if I roll a 5-6, I draw from the weapon deck. So let's imagine that the first time I created the game, I had 25 spaces on the board, and my goal is the game ends when I get to the end of the board, okay? But then we calculated the expected value on a given turn of moving. And because you only have a 1 in 3 chance of even getting the move deck, we determined that your expected value on a given turn is that you move about a half space. Every 2 turns, you would move 1 space on average. And you realized when you figured that out, that a game with 25 spaces would be too long because it would require 50 turns in order to be completed. So you decided to shrink your game to 15 spaces on the board. So it would be roughly 30 turns for the game to last. Now, you then found that the first time you made it, there were too many 3-space cards because the game ended too quickly, because a three moves or movement of 3 spaces is 20% of the board. So you had too many of those and made the game too short. So you limited your 3-space move cards to 10% of the deck. So that was your mathematical reasoning there. Now you could explain your reasoning then for your choices in the gold deck and the weapon deck. That was just an explanation for the move deck. One more example for you. So in our Rochambeau style game, where cavalry, so in this game, me and my opponent each play a card face down, then roll a die and reveal our cards. If I played a cavalry and they played an archer, I get +2 to my die. If I played a cavalry and they played an infantry, they get +2 to their die roll. And if we both play cavalry, nothing happens, it's just the die roll. So let's think about, in this game, the reasoning. Like the big choice here, I think, was to use a 4-sided die and to make it +2 on the attack as opposed to +1 or +3. Why would you choose one or the other? And I can explain it. So let's take a look at if I were to play a cavalry, okay? This is player 1, that's me. Player 2 plays an infantry. So remember, that's the good one for him. I played cavalry, he played infantry, we revealed. He has the one that adds +2 to his roll when we each roll our dice. So if I roll a 1, okay, that's the die, then any roll he has, it doesn't even matter. He beats me, because if he rolls a 1, it gets up to +2, so it goes to 3. So if I roll a 1, then in 0 of his 4 rolls, he has 4 possible rolls, and 0 of them do I win. Okay, so another way to write that more accurately would be the probability of a player 1 win is 0 out of 4. Okay, now if I play cavalry and he plays infantry and I roll a 2, and the probability of a player 1 win will also be 0 out of 4, because even if he rolls a 1, it's worth 3 because he gets +2. Then if I play cavalry, he plays infantry, and I roll a 3. Now I still can't win because his lowest roll would be a 1, which would get boosted through to a 3. But the probability of a tie would be 1 out of 4. I roll a 3, he rolls a 1, he or she, sorry, I'm using he, there's no specific reason. I roll a 1, I roll a 3, they roll a 1. and then we're tied because their 1 is worth 3. And then lastly, I play a cavalry, he plays an infantry, I play cavalry, they play an infantry. My die roll is 4. So the probability that I win in this case is 1 out of 4. Because if I play a cavalry, he plays an infantry, then I roll a 4 and they roll a 1, theirs is worth 3 and I win. And then the probability of a tie is 1 out of 4, because if I roll a 4 and they roll a 2, then it will get boosted up to 4 and be a tie. So all of this is a really long explanation to say that in this case, if I play the cavalry card and they play the infantry card, which beats the cavalry card, gives a +2, then I only have a 1 in 16 chance of winning and a 2 in 16 chance of tying. So I would say that in my game, it's very similar to Rochambeau, because whichever cards we play has the biggest effect on the outcome. But we wanted to add a small chance element. So we have created a game in which it's like Rochambeau, except that with the die element, even if I lose the Rochambeau element, I have a very small chance of winning or tying. Okay? So that would be my mathematical reasoning behind adding a 1, 2, 3, 4 die and adding a +2. Because if this were a +3, I could show you, but basically the die could never make you win. And if this were only +1 on each, then the die would have a bigger probability. And maybe you would decide to do that way to create a bigger chance element. You could explain it in your mathematical reasoning section.